folks. So this is the beginning of kind of a long video, only because it covers a couple different things. It's going to cover some parent resource examples 1 through 3, which can help with the learning that you're doing in Chapter 1 for Algebra 2. But it also has 2 methods and meaning sheets that I want to cover, some notes that I want to help you refresh your memories from possibly Algebra 1, but we'll see. So anyway, let's just get started. So this one's dealing with functions. And a function is a relationship between inputs and outputs. And a function has exactly one output for each input. So if you notice here, every single one on this particular example, all of these x's just have one y. If I was to plug in another 5, and let's just say it was 10, even though it's not going to be 10 because that's not possible. I couldn't have a function if I had a 5 and a 10 there. It just wouldn't work, because then that means it would beat the definition of one input and one output. So every x value can only have one y value. So every input can only have one output. Can't have 2. Now, a function can have multiple outputs that are the same, but not multiple inputs. So if you're looking at this one, functions are written as y equals. And it means that x is our input and y is our output. If we go down to the next paragraph, it goes a little bit more into explaining that x or y is our dependent variable because it is determined by the x value. And x is said to be our independent variable because it determines it. So in our case, 5, when it's plugged into the equation, would be y equals 5 minus 2 squared. And then that would give you y equals 3 squared. So y would equal 9. So our input is 5. And our output is 9. So that means that x determined what the y value was in this case, and that's where it's coming from on the independent and dependent variables. Something that's also important with notation is y equals is the same as this notation. This is read as f of x. That is function notation. The f does not stand for function. F is just the name of the function. But you'll see in Algebra 2 that you will use the f of x more than you will use the y. But when you see f of x, it does behave just like the y. So in this case, if we take our same number set that we were using before, f of 5, because this 5 is our input, equals 9. So that's another way to express function notation. So f of 5 equals 9. So if I input a 5, I'm going to get a 9. And that is what is important to know about the fact that they are the same, essentially. You will see here that I've just added a graph of our equation. This is the y equals x minus 2 squared, which is what we've been using and working with. So I'll just go ahead and write that here so you can remember that. Y equals x minus 2 squared. First of all, this shape is a parabola. Also a quadratic function. So on this one, we're going to start talking about the domain of a function and the range. Domain means all x values. And range is all y values. Let me get that y in there. So over here, I'll use a different color here. This side is our domain, and this side is our range. But it's not by any means all of the numbers. It's just a sampling of this entire graph. If you look here, I would have arrows on this x and on both sides of that parabola going up. And so what we're going to do first is we're going to talk about what is the domain for this particular function. Well, the domain is all x values. That means everything to negative infinity and everything to positive infinity is going to be considered an x value. So I'm going to say that my domain, which we denote here with a D, is all real numbers. Some people will just say negative infinity to positive infinity. That's interval notation, which you'll learn at some point. But it's just all real numbers for right now. And then the range, it's a little different. Our lowest range value is at 0. So that means I have 0 here, but everything for the range goes up to positive infinity. So we would say that y is greater than or equal to 0. And that is how you would denote the range. On the next slide, we'll go into a little bit more about how to enter those things into the calculator and talk about what they look like, and then also what they look like in the tables. So that ends this particular slide. Hi, everybody. So I'm using this particular opportunity to work with tables on TI as I'm getting ready to put this particular equation and the information from it into another video. So I thought that I would start by showing you, first of all, how to enter an equation onto a TI. When I say TI, I'm talking about Texas Instrument, and I'm doing a TI-84. And this is a simulator software that I use, but this is how I teach in my class. And so most of the kids in most of the classrooms that I know of have sets of TIs. So the first thing I'm going to do is I'm going to go with this equation that I've been working with. It's a quadratic, and I'm just going to type in my parentheses x, because that's where my variables are stored. That's where my independent variable is, x minus 2, close parentheses, and then I'm going to go over here to x squared because I'm trying to square that set of parentheses. So that is step 1. Now, if I am clearing my key history just so I can move on and not have it get too cluttered there, I'm going to go ahead and I'm going to hit graph so you can see what that graph looks like. That is a quadratic. Now what I want to do though is this particular equation had a set of values. It had a table that I could use. Now, if you are understanding this particular quadratic doesn't just have integers. It's got all real numbers from left to right for the domain, which is the x values, all real numbers. So it's eventually going to hit everything into negative infinity and everything to the right to positive infinity. It also has a range. The lowest value is a 0 here. So if I went here and I hit second calc and I was looking for the 0, the minimum, actually I'll do the minimum. Let's do that. Let's do 3. I'm going to come down to here. I'm going to hit left bound where I think it is, and then I'm going to go one more over, hit right bound, and then I'm going to hit guess. No, that didn't work. Let's just, okay, clear. I'm going to stop. It is 2 minutes, and I'm going to wait until 2:20, 2:25. I'm going to go ahead and clear all this. Second, mem, 7, 1, 2, enter. Okay. All right, 2:40. Okay. Hello, everybody. So I'm going to go ahead and I'm working with the TI-84 emulator software, and I'm going to be plugging in an equation here and working with it as I'm getting ready to use it in another video. So I thought this would be a good opportunity to do that. So I'm going to go ahead and clear my key history here because you don't need to worry about that. I'm going to go in and I'm going to put this this equation I'm working with, which is x minus 2 squared. So I type open parentheses, my variable of x minus 2, and then close parentheses. And then to get the square, I just come over to this button and hit x squared. Hopefully you are starting to get experience with a TI-84 or 83, but those are the most common ones used in most math classrooms. So I'm going to hit graph. It's going to show me a quadratic, a parabola. I've been talking about domain and range on this one. Domain is all x values, so you can see that it's going to go eventually all the way to negative infinity and positive infinity. So the x values are all real numbers. You're going to see that it looks like our y value, the lowest, we would call that a minimum. Our lowest value is hitting at 2 or 2, 0. So that means we have y values of, which will equal greater than or equal to 0. So everything from 0 to positive infinity for y values is part of this function. But another thing I'm doing on this particular problem is I want to be able to go in and plug in the values from the particular equation that I actually had for this graph. And so first of all, in order to do that, I have to go to second table set because, let's just not do that yet. Let's show you what the actual table is. So I'm going to go ahead and clear. If I went to the tables for this graph and I said second table, you would see that it has all the integers, and I could keep going through negative numbers as well, but this is determined by the calculator. So if I wanted to, I could continue up and just hit this arrow and look at everything in the negatives as well. But I have a specific set of values that I want to check. And so I'm going to start by going second table set, which gives me this screen. I want to be able to type in the independent variable, and that way I can figure out what the y value is. So I'm going to scroll down here, and I'm going to move from auto to ask, and I'm going to hit enter. So now my tables will look like this. They're empty. So for this particular assignment, I have a set of values that I needed to work with. So -2, and remember, this is the negative, not a minus. -2, enter, and then -1. And see, it's giving me my y values as I plug these in. And then we're going to go through 5. So I have all of those particular answers. This is the table that was given as part of the assignment. So I'm done there. I'm clearing the key history because it just gets confusing, but I'm going to go back to the graph and just take a look. And so if I did my trace function on this, which is kind of cool too, you can see one of the values we had was 0, 4. But if I go down and I just move this, it shows you all the different values. So you can see I have lots of decimals and lots of just crazy numbers that you wouldn't actually be able to solve just looking at it. So that shows you how to enter table values and how to look at the different equations. This is also done with the window setting. This is the standard window setting. If I wanted to really mess with it, I could say X value is -100. This will give a bigger picture of the graph. I could say +100 for the X max. And I could just go ahead and set a scale of 5 on this, but it's not going to be as important. Again, I know that the 0 is the lowest number, so I'm going to leave it at -10. And I'm going to go to 100 on this, and we're going to look at what the graph looks like. So I'm going to hit graph. Very different. And so that's by playing with the windows. But if I want it to go back, I can go zoom and standard, which is 6. That will take me back to the original graph. So hopefully that helps and gives you a little insight in how to work with the TI calculator. And we'll talk to you soon. Thanks.